In this lab, I got to choose my own adventure. I decided to drop a yo-yo and determine if the system follows the energy principle. Here is a video I took of the motion. In order to determine whether the yo-yo follows the energy principle, or the change in energy is equivalent to the work and heat transfer, I will make a VPython model of the motion that compares the work to the change in kinetic energy. Then I will put the video into Tracker and get the real change in position data for comparison, so then I can account for any discrepancies in the Python data. I find that the energy principle is verified. Here are the fundamental principles that I will be using. As shown, the energy principle states that the change in total energy is equal to the sum of energy changes, particularly kinetic and potential. Furthermore, the change in energy is also equivalent to the work done by the surroundings. In order to update the position of the yo-yo through iteration, I will be using Newton's second law as well. This way, I will have an updated velocity and position for each run through the loop. Just to clarify, I have chosen the yo-yo to be the system and the surroundings to be gravity, with the work equal to the force multiplied by the change in height. If I had chosen to exert some force with my hand, this would also have to be taken into account. However, for simplification, this is not the case. Here is my code. I put in the yo-yo's mass, initial velocity, and position. Then I set my time step to something very small and set the gravity on Earth constant. I put in the formula for kinetic energy to find an initial value and then calculate the change as well as work in my loop. Here is a closer look at my loop. I set the work equal to mgh and defined the change in kinetic energy. I also use Newton's second law to update the track, as shown here. Then here's what my code looks like when it is being run. As you can see, the yo-yo falls in the negative y direction due to gravity. Then the correlation between work done by gravity and the change in kinetic translational energy are shown. Here I printed the values calculated by VPython, first for the work and then the change in kinetic energy. There is a very small discrepancy, but not enough to falsify the energy principle. The main source of error present in the code would be not accounting for drag force or tension when calculating my net force on Python. Here I am shown putting the real system video into Tracker and then determining the change in position. Note how in the beginning the yo-yo takes off in the negative x direction. This is due to a small force caused by my hand that I will neglect in my calculations. Then I compare the position data on Tracker, shown by the blue dotted line, to the position predicted by the Python model, as shown by the solid blue line. The Python model overpredicts the position because I do not account for tension or drag, acting in the negative y direction. This will influence the change in kinetic energy in the model. In conclusion, the simplified yo-yo system verifies the energy principle is accurate and is capable of describing how energy is conserved in the universe.